Okay, students, here's a review for your Mod 2 Topic 2 test. The reasons that you'll be used on the test for your two proofs, definition of right angles, so that means all right angles are 90 degrees. So if you have two segments that are perpendicular, they would be 90 degrees to each other, and you use definition of right angles for that justification or reason. Definition of congruence, okay? That means I can say two sides that are equal in length can become congruent, or if I start with congruence, I can go to saying that those two sides are equal in measure. Definition of congruent segments, same idea as definition of congruence. Subtraction property equality, subtract the same number from both sides. Segment addition postulate, when I add two adjacent segments together, collinear segments together, they add to the large segment, the two put together. And substitution property, remember another name for that is transitive property. Okay, it's often intermixed, transitive property. So if A equals B and B equals C, then A equals C. Or you could just substitute in A equals C for substitution. Okay, you need to know your triangle sum theorem. It says all the angles of a triangle add to 180. Be able to solve it with not only numbers, but with variables as well. You're still adding them all up, set them equal to 180 and solving. Sum of the interior angles of a convex polygon. So you have a pentagon, hexagon, etc. I want the total degrees of the interior angles. It's n minus 2 times 180. If I want the actual angle measure of each angle of that regular polygon. So notice the first one doesn't have to be regular. It can be any convex polygon. It's n minus 2 times 180. Remember, the n minus 2 is the number of triangles that can be drawn in 180 degrees for each triangle. When I draw a diagonal from all the diagonals from one vertex, that's the n minus 2. And of course, each triangle adds 180 degrees. That's why you're multiplying by it. So if I want the angle measure of a regular polygon, I need to first do the total degrees of the interior angles, which is the n minus 2 times 180, and then divide by the number n. That will give me the degree. That's only for a regular polygon, not for just any convex polygon. The sum of the exterior angles of any polygon is 360 degrees. That doesn't change whether it's quadrilateral, pentagon, hexagon, etc. If I want the individual exterior angle of that regular polygon, since I know the total is 360 degrees, I divide by 360 divided by the number of sides. N is always the number of sides or angles. Linear pair theorem, you should know that if I have a linear pair like that, the measure of angle A plus B is 180 degrees. Okay, linear pairs are supplementary, which means they add to 180. Next, we have our particular type of inscribed angle. We go over here first. We know all inscribed angles equal half of the intercepted arc. Well, if I go ahead and look right here, if I connect any angle to the end of the diameter, that arc measure right there is 180 degrees. So half of that makes it 90. So anytime I draw right there, if I go to the end, that's 90 degrees. I don't know why I didn't do it. If I go to the end over here of the diameter, each time, still 90 degrees. Okay, it's half of its intercepted arc. You also have to know isosceles triangle theorem, which you know an isosceles triangle is at least two congruent sides. The isosceles triangle theorem says the base angles are equal. So I know that those two are equal measures. Let's say they tell me one of those was 50, then I know the other one has to be 50, and then this one, that's 100. So that means this should have to be 80. Now they're going to go ahead and give you some algebraic expression there. Let's say they say 2x plus 10 right there. So then I set 2x plus 10 equal to 80. Subtract the 10 across, I get 2x equals 70. And then last step, divide by 2. And 70 divided by 2 is 35 for x. Okay? Gotta be able to do that basic stuff. All right, interior angles of a circle theorem. So here's interior angles. Remember, it's not a central angle. It's not connected to the center. Just some interior angle in the circle. So these are two chords. Remember, those are called chords. The chords intersect. To get these two angles right here, which are vertical angles, so they're equal. To get both those angles, It is the midpoint of the two intercepted arcs. So that arc, intercepted arc there, and that intercepted arc. If I just find the midpoint between 60 and 120. Well, how far from 60 to 120? 60. What's half of 60? 30. So I add 30 to 60 and I get 90 degrees. So it's actually 90 degrees right there then. Or I subtract 30 from 120 and that's 90 degrees. The other way you can do it, as the book would say, is you add the two intercepted arcs together and divide by 2, and that gives you 90 degrees. That's the midpoint. Okay, then we have the exterior angle theorem of a circle. That is the outer arc minus the inner arc divided by 2 equals the measure of the exterior angle. Oops. Equals, we'll call this angle 1, so I can write it smaller and get it in there. Measure of angle 1. That's a 1 there, not an arc. Okay, so outer arc minus inner arc divided by 2 equals that. They have to give you 2 of those 3. So they might give you the outer arc and the angle, and you find the inner arc. Or they might give you the inner arc and the angle, and you find the outer angle. That just means you put the variable on the one that's missing. Okay, you're solving an equation. All right, next we have 30, 60, 90 degree special right triangle. And here's our relationships right here. So we'll just do the hardest one only. So let's say they tell me this is 12. I should know that's the 60-degree side because it's across from the 60-degree angle. And it tells you right here on the 60-degree side, it said equal to a root 3. So I need to divide by root 3. Now I need to rationalize my denominator. Change it to a rational number, right? Square root of 3 is irrational. So you get 12 root 3 over 3, which then simplifies down to 4 root 3. That is what A is. Well, what does it tell me A is? A is the 30-degree side. So that makes the 30-degree side right there 4 root 3. How do I get from the 30-degree side to the hypotenuse? I double that. So that makes it 8 root 3. You do not double the radical, you just double the coefficient out front. All right, so that's the hardest one you can have there. And we have our 45, 45, 90. Okay, obviously the two 45-degree sides are exactly the same. So again, I gave you the hardest one when I gave you the 90-degree side, the hypotenuse. You gotta know it's the 90-degree side, also called the hypotenuse. It's across the 90-degree angle, or the right angle. So it says set it equal to a root 2. Okay, so I now need to, let's do the work over here. I need to divide by root 2. Then I need to rationalize it. Oops, root 2. It's always multiplied by the same number. So I get 12 root 2 over 2, which then simplifies down to 6 root 2. So each of the 45-degree sides is 6 root 2. Now, I could guarantee I'm right because if I know that I go from how do I get from the 45-degree side to the hypotenuse is I multiply by root 2. So if I multiply 6 root 2 times root 2, you notice root 2 times root 2 is 2, times 6 is 12. Exactly what I have right there. So I know I am right. Okay, so you can always check that answer by plugging that back in. All right, lastly, you need to know your angles from early on in the year and from 8th grade geo if you were taught it correctly. So we'll do the corresponding angles last because that's the hardest one. You can't just tell from the name. SSI, same side interior angles. Same side, they have to be interior, 3, 4, 5, and 6. Same side, 3 and 5. One pair, same side, 4 and 6 is your other pair. Alternate interior angles. Alternate means diagonal. They got to be inside. Again, change the color. So 3 and 6. It's one pair, and 4 and 5 is my other pair. Alternate exterior. Again, that means diagonal, but they have to be the exterior angle. So 1, 2, 7, and 8 are my only options. The diagonal ones are 1 and 8 and 2 and 7. And same side exterior. Obviously, I'm choosing from the exterior, and they have to be the same side of the transversal, 1 and 7 or 2 and 8. Okay, now what are their relationships? Oh, corresponding is last. Corresponding, we have 1 and 5. Okay, 1's It's always on the same side. One's exterior and one's interior, but they cannot be adjacent. So it cannot be 1 and 3. So 1 and 5 is one pair, 3 and 7. Then we go to the other side of the transversal, and we have 2 and 6. And we have 4 and 8. Okay, for corresponding angles. So what's true about all these pairs of corresponding angles? They're always congruent. What's true about the same side interior angles? They're always supplementary for each pair. Alternate interior angles are congruent, alternate exterior angles are congruent, and same side exterior angles are supplementary. So how is it easy to remember which ones are the two that are supplementary? They both start with an S. Same side interior or same side exterior are supplementary. All right, that's all the information that you need to do well on the test on Mod 2, Topic 2.